Okay, so it's recording now. So today is going to focus more on SQL Server's architecture, right? Because even any RDBMS solution that you want to learn, the first thing you want to know is their architecture, because they all have their own architecture. And if you don't understand the architecture behind the RDBMS, let me actually mute you guys. So if you need to say something, you can just type in. All right, you can send a message in the chat box. So I've decided to mute you guys so that it doesn't distort the recording, but I believe you can hear me. Just send a message if you can hear me still, so I know that I'm not talking to myself. All right, so like I was saying, you would need to have complete and ample understanding of the architecture of any RDBMS you want to start managing as a DBA. Okay, because you'll find out that if you're working on Oracle, for example, and you also have the skill set to work on SQL Server, the moment you get off your Linux box and you log into SQL Server, it's going to be like a shift in your direction. So you need to deal with it based on the understanding of the architecture of the RDBMS solution you're working on, because they have a wide range of differences. Okay, so yeah, so that's very important, and that's the reason why I've chosen to discuss the architecture first before we move on to other things. And after this session, like I said before, you will be given series of projects to do. There are so many projects I have lined down for you to lay your hands on, and you should bear in mind that you'll be doing these projects as though you are doing it for your company. So you'll be doing it with the best practices in mind. Okay, so for example, it's a different thing when you install SQL Server just because you want to learn how to code in SQL. You don't have to bear a lot of things in mind when you're doing that. All you need to do is just run the installer, install it, and start learning your SQL. But as a DBA, you want to install SQL Server with the understanding that a lot of users will be depending on it. You want to install it with the understanding also that there will be growth expectation. So you want to plan the installation and have something concrete in terms of capacity planning. All right, so these are the things that we will have in mind when we're building the different solutions. So it's not just about the installation now, but it's also about the different implementations that we'll be working on. Again, I need to say that this implementation will now have a lot of components attached to them. And what do I mean by that? For example, the first series of videos will be to build your infrastructure. And building your infrastructure means you have your own domain controller, you have your own different servers, okay, that you will install SQL on. And that's the way it will be at the place of work. Obviously, no one would ask you to go and configure domain controller when you get to work. But if you don't practice with having domain controller, in your environment, you'll find out that certain things will be missing, such that when you get to work, it will be easy for people to tell that, oh, you don't have any experience. So that's why I've decided to say, okay, let's have a domain controller as well, and we will build it as such that it is a proper enterprise infrastructure, so that you can create users, you can create service accounts that are coming from the domain controller. There are a lot of things that need to be borne in mind, for these things, and building your environment will bring out all these different components. So part of the components I'm talking about again is performance tuning. So you will be faced with several scenarios of performance hit. You'll be faced with several scenarios of disaster that you would have to restore from, recover your database, maybe to a point in time recovery, or to, or it might actually be a case where you have to recover just a page or just a table or file group, as the case may be. So that is like giving you a lowdown of the expectations to come ahead. So having said all of this, let's delve into today's lecture. So it's going to be slides all through. It's just a couple of slides, 7 of them, and yeah. So the major components for SQL Server are 3. So we have the Relational Engine, we have the Storage Engine, and we have the SQL operating system, and it's popularly called the SQL OS. So we'll go into each of these in detail. And just as you know, if you're from an Oracle background, for example, you know that, as Oracle is a one-to-one relationship, SQL Server is not like that. So Oracle, you have your database and you have the instance, which is nothing but the memory structure and the processes and all of that. But SQL Server is a little different from that. All right. So the component that SQL Server has is the Relational Engine, the Storage Engine, and the SQL OS. So we'll come to that in a moment, but then I want to quickly talk about the client-server architecture as well. So for someone who is completely new to IT, may not have this understanding, but I would imagine that you already have this concept, but if you don't, that's fine. So client-server architecture is nothing but a scenario like this, where we have the client, which is the desktop or browser, and we have a layer in between, which is the application, and then we have the database layer. And what do we mean by the client layer? So take Facebook, for example. If you pick up your phone or your laptop or your iPad or any of those gadgets, and you open up a browser, and you put in your username and password to connect to your Facebook application. Now, your desktop, your phone, and the browser that you brought up to connect to Facebook, these are the client. All right. So these are the clients, and there is a layer between the client and the database. So you can imagine when you post your photos on Facebook, your photos go somewhere. If you go to the folder in your account that says photos and you click on them, you'll find out that your pictures return back to you. Now, those pictures are coming from somewhere, and when you post them, they get saved somewhere as well. And the places in which they get saved, as you know, is the database. But you don't go straight to the database from your client browser. You obviously have to go through a layer, and that layer is the application layer. And we have programming languages like .NET or Java or Python or any of these object-oriented programming languages that do all this job for us. So where you as a DBA lie is the third part of the equation here, and I want to believe that's the reason why sometimes they call DBAs third line support, because we're not first line. We actually sit at the very back end. A lot of people on this side, which is the client side, don't even know that we exist, but DBAs actually make things to work, make things to run, because without the database, you can imagine the client can go to Facebook, click on www.facebook.com, and the page actually comes up. You would see the Facebook page, but when it's time for you to upload your photos, it doesn't get nowhere. Or if you want to retrieve your photos, it doesn't get nowhere. So this is where the layer actually stay. So I'm not going to spend too much time on this, because I would imagine that you have understanding of this already, but just to fulfill our righteousness, we have to talk about it. So going to the meat of the whole thing, the first part of the architecture I want to talk about is the Relational Engine. So this is the main engine for SQL Server, and when we talk about relational engine, there are a lot of components within it that makes it the relational engine. And it's also called relational engine because SQL Server is a relational database management system. All right, so the engine that makes it to work to do its relational job is called the relational engine. Okay, and there are a number of components, like I said. So it's for example, the first bullet point here says it's also called a query processor, and it's responsible to determine what exactly your query needs to do and the best way to do it. So when you type in your T-SQL code, you would rely on the relational engine to determine what your query needs to do. So because there are queries that are data analysis inclined, there are some that are database administration inclined, there are some that are development inclined. So you can imagine if you write a query that has to do with creating a login, the relational engine understands that you're not trying to pull data from a table, okay, but then it understands that it needs to create the login and store that information somewhere, so that if you need to do some auditing or to go back in time to know when things actually happen, you can still query the same engine and it will take you to the right place that you need to go. So that's one of the things that the relational engine does, and it's also called the query processor. So it processes the query. All right, so now moving forward, the next one says it manages the execution of queries as it requests data from the storage engine. So we'll go into the storage engine in a minute, okay, but its job is to execute the query, not to return the data. All right, so the whole execution of query is a mathematical thing, because even though you write T-SQL, the relational engine does not understand the T-SQL that you have written. What it understands is the machine language. So the parsing and the understanding of the T-SQL is done by the relational engine. And if you look at this part of the slide, it says that if you look at the query parser, it says it checks that your syntax is correct and compiles it to machine language. So if you write your T-SQL, the relational engine passes that syntax, because if it's not correct, the machine language will not be able to do what you ask it to do, right? So this whole thing, it's a lot of work that happens within the engine. It keeps working like a clock. Even when you are not running any query, there are things that are happening behind the scene. So your session might be idle, but the engine itself is not idle, because there are a lot of work that are happening. So the query parser, like I said before, will move your T-SQL syntax and then compile it to the machine language. And what do we mean by the machine language? It's the binary things that you see about computers. So it's just 0 1 0 0 1, like that. When you see things like this is machine language. That's what the machine understands, and it has meaning. So for the hardcore programmers, they can actually understand these things, but given the fact that it's what the machine understands, not everybody can do that. So the best thing to do is to have a language like SQL, which will then be compiled into that language. So I missed this last part. It was on purpose because I needed to quickly talk about that. So the last bullet point here says it processes the returned result. So even when you write your SQL and then send it to the storage engine, which we'll talk about soon, the result that is being presented to you is being processed by the relational engine itself. Okay, so you need to bear that in mind as well, so that this understanding is quite important, so that when you're having issues with having to do performance tuning, having the understanding of the relationship between the relational engine, the storage engine, and the SQL OS, you can easily direct your attention to the right area, rather than just doing guesswork or trying to model things around. All right, so it also consists of something else called the query optimizer, and the query optimizer is also very important, because when you write your TSQL query, something has to be able to tell the engine the best way to get the data back. Because I mentioned the other time that all these things are mathematical concepts. So for example, let's say, let me bring up this. So there's a concept in mathematics called permutation. Yeah. All right, so we're not going to go into any mathematics here. It's just that it's important for our understanding. So if you have a query that you want to run, your engine will decide on the best way to actually get the query back to you. But given permutation, it will check the different, possible ways in which it will return that one data. So even if you wrote select one, which is like the simplest query that you can ask the engine, and given that one is not a data that resides on the table or anything, but it still needs to present it somehow. Now, the relational engine can have up to 10 different ways in which it can present just this singular data. All right, so the query optimizer part of the relational engine has the job to choose among these 10 options that are available to it. It has to choose the best one out of it. So you can imagine there are certain queries that will have up to, sometimes it might even be up to 500, it might go up to 5,000 different possible ways in which a query can be returned back to the user. And out of these 5,000, the relational engine also has to make a decision to use just one out of it. So you can imagine how much of work it has to do, especially when you have to run a very huge query. All right, now, so query optimizer here says it determines the best approach by preparing the execution plan. So I'm sure this term is not new to you, but if it is new to you, then that's fine. Execution plan is the result of the one decision that it had made out of the whole permutation of options that have been made available to the relational engine. So that execution plan also happens as a result of other things, because SQL Server has to rely on some inputs for it to be able to make that one decision. And what are those inputs? It takes the query, which obviously we would have written, and it takes something called the statistics. Okay, we'll go into statistics during the course of the program. And then it takes something called the algebraizer. Okay, it's popularly called the algebraizer tree together, but some people actually just call it the algebraizer. And it takes these three things as its input. Now, what do we mean by the algebraizer? That's the part where it checks the existence of the table and the column. Now, it is not checking if your syntax is correct or not, because they mean two separate things. It's one thing to check if your syntax is correct. If your from is followed by the select, or if the order by comes before the group by, all those things, that's what we mean by the syntax. But the algebraizer just checks if the table exists, or if the spelling for the table or column is correct or not. That's just the job of the algebraizer. So once all these inputs are being passed to the query optimizer, which is a part of the relational engine. Then it is able to prepare an execution plan. So that means if any of these things are wrong, let's take the query out of it because that's the user input, right? Now these are not user inputs. These are other things that are happening within SQL Server. So if any of these things are wrong, what that means is it's going to affect the execution plan. And when we go deep into performance tuning, you will understand that these are the areas in which we're going to be focusing on to be able to tune for the best performance. So we have this other one that says query executor. So this is the part that goes to fetch the data following the execution plan. So it's the data does not actually reside in the relational engine. So when we get to the storage engine, that's where the data actually gets resided. But the query executor, after passing through this phase, goes to fetch the data for us from the storage engine. So this is just a highlight of the things that we mentioned before, but a little more in detail. So we have the query processing, which we have talked about. Now, there are other things in which the relational engine also do, which is the memory management. So unlike what we have in Oracle, where you can manually manage your memory, or I think it was from 10G or so, they introduced these automatic memory management, whereby you can just specify the values, the minimum, the maximum values, and then you leave the engine to manage the memory. Now that's exactly what we have in SQL Server. You don't manually manage the memory. I've never seen anyone that does that in SQL Server. You leave the total memory management to SQL Server. But there are ways in which you can optimize this as well. All right, so we'll get into all of that in detail in due course. So, but bottom line, the memory management is what the relational engine does. It takes care of that, and it does the thread and task management as well. So what do we mean by thread? So if you run a query, for example, that thread, depending on the logical CPUs you have for SQL Server, your query is being distributed into threads. So SQL Server Relational Engine manages this thread, and it gives the memory to the ones that need it. It releases the memory from the ones that don't need it, or the one that shouldn't be having that much memory. It does all this intelligent stuff. And this is the part where SQL Server is becoming, one of the top relational database management system today. If it was 20 years ago, I've read a research that proves that I'll find the information for you, and I'll send it out to you guys if you're interested. But I've read research that says that 20 years ago, SQL Server may have actually been one of the worst management system you could think about, because Oracle has always been number one, right? And no one could write anything good about SQL Server. But that's quite understandable because it was just starting off at that time and it was not mature enough to do a lot of things. 15 years ago, maybe, yes, but from 10 years ago, which is that would have been from 2006, the release of SQL Server from that time was the 2000 version. From SQL Server 2000, there was a complete redesign and rebuild of SQL Server engine. I mean, it was a case where they had to destroy what they had before and completely rebuild the operating system that SQL Server uses. And ever since, they have done a great deal of job moving from 2000 to 2005 to 2008 to 2012 to 2014 and now 2016, they have done fantastic job. And that's the reason why today Oracle is now struggling. I must say, Oracle is now struggling because Oracle is a complex system, and people are now seeing that, companies are now trying to move their system from Oracle to SQL Server, because part of my previous roles as a DBA, I have been on the projects where we had to migrate data from Oracle to SQL Server. And this is one of the things that will easily tell you, okay, something is going on here. And apart from the fact that Oracle is such that it's all code and it has to run on the command line and all of that, even though yes, you have the cloud control and all, but there are client tool like SQL Developer and all of that. But what SQL Server is doing with Management Studio, you cannot compare with what you can get with Oracle. And I think it's one of the reasons why people are now beginning to shift their attention, and there's a lot of jobs now happening on the SQL Server side. So at the point where SQL Server started introducing these things into the relational engine, that's where the management system started becoming very, very mature and advanced. So all these thread and task management things are very, very fantastic things that SQL Server does. And obviously this has to do with memory as well, which is the buffer management, because the way SQL Server works is whenever you want to update a data, what it does is it pulls the data from disk and put it in memory and does the insert in memory and all the DML before it gets written back to disk. And even if you want to retrieve data with your select, whatever happens has to come to the buffer first. So this becomes highly important, which is the buffer management. So part of the things that is being done by the relational engine is the buffer management. And finally, we have the distributed query processing. And what do we mean by this? It is now very possible for you to have an instance of SQL Server, and let's say in America, for example, you have another instance in Europe, you have another one in Africa, and you can do a distributed processing across these three environments, such that you can have a stored procedure that will return data back to you, and all the data was retrieved from all the different tables sitting down on all of these different environments across the world. So that's a part of the distributed query processing. And obviously you can imagine for this to happen, if it's a transaction, for example, which requires a commit on the server in America, it requires a commit on the one in Europe and the one in Africa as well. You can imagine that all of this transaction has to be processed as one, okay? Because if it commits in America and it doesn't get committed in Europe, for example, and something happens between the line, maybe a power failure or that is affecting where the stop procedure was initiated, now you would eventually have inconsistent data, because the data got committed in America, but in Europe where it didn't get committed, it got rolled back. And that transaction was actually meant to run as a whole, as one. Imagine if it was a bank transaction where you're moving money from one account to the other, So this is very important to the consistency of the data. So the relational engine actually manages this such that we don't end up having inconsistent data. So in the middle of this kind of operation, if anything happens, the relational engine is smart enough to roll back the entire data, even though it initially got committed somewhere, because it understands that it is not just a transaction happening on one server, it is a transaction happening across multiple servers. So that's the distributed query processing. And there's also distributed query processing within one instance as well, because you can have multiple databases in SQL Server, such that let's say you have database A, B, and C, such that you have a store procedure that retrieves data from all of these databases. By the time we start our installation and all of that, you would understand, how this looks. Now, the distributed query processing also manages this kind of thing, but there are exceptions to this. So when we start putting our hands onto different technology and solutions, you will see where you can use one against the other. So this is pretty much everything you need to know about the relational engine. So it might come to you in the form of interview questions, but given all these things, you shouldn't have any issues explaining them at all. So moving on to the storage engine part of the architecture. Now, this is the part that's responsible for the storage and retrieval of the data onto the storage system. So we talked about the relational engine before, which takes charge of the query, the parsing, execution plan and all of that stuff. But the storage engine itself is where the data sits. So you want to write the data, it goes into the storage. You want to retrieve data, it gets it back from the storage. So this storage engine is responsible for managing the locking and data manipulation and transactions. And what do we mean by this? So the storage engine understands that if you flush a transaction that has not been committed, that is not been completed yet, but as a result of something we call checkpoint, if it get flushes to disk and something happens, like a disaster strikes. Now, with the power of storage engine and the locking mechanism that it has, it can still roll back that transaction such that you end up having a consistent data inside the storage of your database. So when you bring back the system up again, you don't find yourself in a situation whereby, even though it got committed as a result of checkpoint before, you now start having issues where a part of the transaction gets committed and the other part doesn't get completed. But talking about transaction, we will go deep into transaction as well in due course, because there are a lot of areas we need to look at on that angle as well, because there are isolation levels that help us to manage transactions. So moving on is the storage. In the storage engine, it consists of the following part, and this part we're about to talk about is very important, because even though it is a very important part of the interview process, some interviewers would like to know your understanding, would like to test your understanding on this, so they can ask you a few questions in terms of data pages and all of that. So I would implore you to take attention to this area a lot. Okay, so the storage engine consists of the data file, okay, and this data file is similar to the one we have in Oracle, which is the DBA file, and in SQL Server it's called the MDF file, and MDF means master data file. So in Oracle it's DBF. I don't know what DBF means, but I would imagine it's database file or something like that. So this is the file that physically stores the data in pages. Okay, so what do we mean by pages? When you write a data into SQL Server, it doesn't store it as you would store a text file or an Excel file or a WordPad file. It breaks the data into something called pages, and these pages, each page is actually 8 KB in size. So, and that's the point we're talking about here. So it stores data in the form of data page, which is 8 KB, and these pages come from different objects such as tables and indexes. So So talking about the tables and indexes, so when you create a table and you put data into the table, you know, that is being stored in 8 KB. All right. So when you have let's say a table, for example, let me bring this up. When you have a table, no, actually not this, let me use shapes. So you have a table like this, and you bear me 1 second, let me use a marker to explain this concept clearly. All right, so if you have a table like this and which has rows, it has rows like that, you know, the moment you start putting data into it and given the data type that each column takes, so let's say for example this is an integer data type, and we know that integer takes, for example, let's say it takes 4 KB. So let's say it takes 4 KB, that's just an example. If you put one record, you know, like an entire row into this table, that record might actually take as much as, let's say, 24 megabytes, for example. This 24 megabytes, if you divide it by 8, that will give you the total number of pages that this row gets stored. So that's what we mean by the 8 KB pages that we're talking about there. So SQL Server stores each record that you insert, it stores them as pages. So you can imagine if you have a table that is, let's say, 100 gig inside, and I mean this is a lot more than what's it called, a lot more than megabytes, you know, divide that by 8 KB, that will tell you how many pages that you would have. Now the thousands or millions or billions of pages that are being created inside the storage engine, that is what causes the IO bound thing, you know, that you get to hear about from time to time. You know, you come across that word IO. IO means input and output, and this is one of the things that makes the DBA work very, very interesting, because it is left for the DBA to manage this. It's left for the DBA to understand how to plan the installation, how to plan the environment, such that the billions or millions or hundreds of millions of pages that are being created in the storage engine are being managed properly. Because if there are so much and you get to a point where you start having fragmentation, you know, we'll talk about fragmentation also when we start talking about indexes. When you start having fragmentation and all of these things, you'll find out that you start having performance issues. And this is the core of every DBA. Performance issues will always happen. You will always have performance issues. But understanding that you're having to deal with hundreds of millions of pages is something. All right? Okay. So having said that about 8 pages, because there are different types of pages that we'll talk about as well. These pages are also logically organized in extent. And what do we mean by extent? Extents are logical units also in the database. So it's just a way to organize our pages, and they are a combination of 8 data pages. So for every data page that we have, for every data page that we have, let's say this is a data page, this is a data page, this is a data page, you know, like that. For every data page we have like that, the moment it gets to 8, 1 2 3 4 5 6 7 8, it becomes an extent. So it's just a way to organize our pages. So you can have a lot of extents inside the relational engine. and each of those extents contain 8 pages each. So that's what an extent is. So it's just a logical container, you can say that, of pages. And what for here it says 64 KB makes an extent. So that's also straightforward, because if you have an extent that contains 8 KB of pages, if you multiply 8 by 8, you get 64 KB. So every extent has the value of 64 KB. So extents are two types. So we have the mixed extent and we have the uniform extent. So what do we mean by the mixed extent? So these hold different types of pages, like the index, system, data, multiple data pages from different objects. So let me use the marker to also explain this one. I'm going to change the color this time. All right, so remember we had our table the other time. So let's say this is our table and we have our rows, and this record is, let's say, 8 MB, and this record here, what do I mean by record? I mean rows. Rows are also record. So this row may actually be 64 MB on its own. So depending on the data that's been inserted into the row will determine the size. Now, for this 8 MB, you can imagine that the pages, then we're having to deal with 8 MB divided by 8 KB. So I don't know how many that will come to, but we'll have all of that in pages inside an extent. Now, this other row here, when it gets inserted, let's assume that in this extent we already had just six pages there already. Now it will get to a point where, if let's say deletion happens, part of this extent, these pages gets removed from the extent, and we will now be left with maybe 4 of them. This one that has 64 MB, the moment part of its pages comes into this extent, it won't fill up everything. So what happens is the remaining will now be flushed into this page. So an extent that has different data pages from different sources, so let's say this 64 MB was actually coming from another table, for example, then we will say this is a mixed extent because it has pages from different tables. So one table, some of its pages are here, another table, because it finds some space, it just pushes some of its pages into this place, so it becomes a mixed extent like that. So that's why they call it mixed extent. But there are some other ones that all the pages inside the extent are contiguous. So meaning everything belongs to the same extent. So that's the one that is uniform. So, and that's why I've written here that uniform extents hold pages from a dedicated object type. So it could be index, it could be table, it could be anything. So this takes us to the types of pages that there are in SQL Server. So each of those pages that we talked about, that is 8 KB in size, there are different types of them and they all play different roles. So we'll start with the data page. So this is the main data for tables, data that have been inserted into tables in SQL Server. So the data page holds data entered by the user, excluding these data types. So these data types, text, ntext, nvarchar, varchar, verbinary, image, and XML. The reason is because, let's take this one out, for example. I'll bring it back. This text, ntext, and verbinary marks, image and all of these ones, except XML. Yeah. So think about this text, ntext, verbinary marks all these ones, even image, they are going to be deprecated from SQL Server. So it will get to a point where SQL Server will not get to use them at all anymore. So, but these ones are actually exception to them. But at least those ones, we know that they are getting deprecated. So it's one of the reasons why you can think about it that, you know, data pages don't hold them, because number one, think about it, mVirtual Max, its value is, I think, you know, it's more than 4,000 bytes. All right, so it's not, you know, the data page is not created for that, to hold, you know, that kind of data. And similarly, binary max, you know, binary is used to store binary data like images, pictures, you know, files and all of that, but it's variable binary. So these are very large, you know, data types that it's not used by the data page. On the other hand, we have the index page. So these only hold index entries only. And then we have the text and image, and what these hold is large objects. So all these data types that we talked about that data page does not hold is being held by these text and image page types. Now things get more interesting when we start talking about PFS, GAM, SGAM, BCM, and DCM. You see all these ones, you know, they are more like metadata pages. And what do we mean by that? You know, metadata means data about data, and page free space, which is the PFS, usually they are internally used to manage allocation of pages. Now, what do we mean by that? Whenever a data is being allocated to pages, that data is being written somewhere, so that when it's time to troubleshoot, you can also link things back to where the data is being recorded. So a record that keeps track the allocation of pages is being, you know, placed into this data page called the PFS. All right, so it's used to determine unused spaces as well. So, you know, like the extent that I showed you the other time, we're not talking about extent here, we're talking about the page itself, so don't get it mixed up. So for the page, you know, as part of the page, the little page, the 8 KB page, any part that is not being used, that information is being saved by the PFS, right? And any data that is also used is being saved by the PFS. So that's just all you need to know about that. So if you're being asked at the interview, for example, that what does PFS mean, you can explain that it's just a type of, you know, page, and the interviewer will not expect you to just say that only. You can go on into the discussion to let them understand that what you're talking about has to do with part of the architecture of SQL Server, which is the storage engine that holds, you know, the pages. And there are several types of pages, one of which is the PFS that you've asked me about. And what it does is it's used internally to manage the allocation of pages, and it's also used to manage, you know, and also to determine the unused spaces. Because think about it, if SQL Server wants to write data to a page, it needs to know the ones that are free, isn't it? So it goes into the PFS to get that information so that it can lead it to where it needs to go to write that data into the page. All right, so GAM and SGAM, it's just like the PFS, but in this case we are now talking about the extent. So they're used to internally manage allocation of an extent. So the full meaning is global allocation map, and this other one is called the shared allocation map. So generally speaking, both of them do this thing, which is to internally manage the allocation of extent, but then they still have individual work in which they do. I'm not sure, I don't know about it, so that's why I didn't write it down here. But in the course of the time, if I get any information about that, I can let you know, and we can all learn together. So there is this I am page as well. And what does this do? If you need to know the specific extents that are used by a table or index, you know that extents, be it the mixed or the uniform, are being used by different objects, right? And those objects could be table, it could be index. So if SQL Server wants to know which extents are being used by a table, it queries the IAM page, which is the index allocation map. So it uses this page to identify the specific extents that are being used, and it can identify that, okay, this extent is being used by a table, or it is being used by an index. So it stores the information per allocation unit. So for every allocation of the data, it stores this information inside the IAM page. Then we'll move on to the BCM. The BCM is called the bulk changed map. So BCM and DCM, they are actually similar. So one is for bulk operation, the other one is for database backup of operations. So what they do is the BCM holds information about extents that are changed in a bulk operation. So anytime you do a bulk load, you issue the bulk insert command, or you issue the BCP command, or any of those bulk operation that's been done within SQL Server, that information is being stored by the BCM page type, and it stores it for the extent. All right, so the other one is similar to that, but it only stores it when you issue this command, which is the backup database, and that's the command we use to backup databases. So this is pretty much about the storage engine. Nothing much more that you need to know, but in the course of time we will still make references to certain aspects of this, because we'll talk deeply about indexes and fragmentation and statistics later on, and we'll have to keep going back and forth talking about storage engine and IO and all. So moving on, the final part is this SQL OS. All right, before I talk about the SQL OS, there's another part of the storage engine that continues here, so which is the log files. So it's also called the write ahead logs, and this stores it's the file that stores modification to the database, and the extension for this one is LDF. So it's just like the MDF file, but in this case there's another file. So when you create the database, two files get created, the MDF and the LDF. So the other part, which is the LDF, is the log file, and you can think about it as the online redo log that we have in Oracle. So it's just a place where it stores modification, DML, operations that happen in SQL Server, and you use it basically for these purposes. So in case you want to roll back transactions, you can SQL Server uses the log file to do that. If you want to recover the database in case of a failure, you can recover to a point in time and put the database to a point of recovery, because there's a difference between restoring a database and recovering the database. So to actually recover, you would SQL Server uses the transaction log file, which is the LDF file, and you also use it to maintain the ACID properties. So when we start talking about transactions, we will see what ACID means, but for now just know that it means ACID, A for atomicity, C for consistency, I for isolation, and D for durability. But we'll come into all of that in due course. So finally, about SQL Server's architecture is the SQL OS. Now this is also new. This SQL OS was actually introduced in 2005, and it's part of the maturity we're talking about SQL. It's getting mature every day, So in 2005, this SQL OS was actually introduced, and it's now a very, very huge part of today's SQL Server, and it's growing on and on and on like that. So this lies between the host machine OS and the SQL Server. So it's like a thin abstraction layer between the host operating system and SQL Server engine. So SQL Server has its own operating system. All right, we know what an operating system is. So like we have Windows Server or a Linux operating system. The operating system manages all the threads and all the activities going on the system. So similarly, SQL Server has its own operating system that manages all the threads and CPU, workload and all those things that are happening. And the reason that Microsoft had to introduce this SQL OS is for something called there's this concept called the preemptive and non-preemptive scheduling, and we'll get to that in a moment. Now, SQL OS can be regarded as a bridge between host OS and SQL OS. I've said that, and each instance or installs its own SQL OS. In comparison to Oracle, with Oracle you can also install multiple instances on a server. But I mean, why would you want to do that? Because both Oracle and SQL Server are memory hog. Okay, they're very selfish. So you can imagine the load that you will be putting on top of the entire OS, having multiple instances or multiple installation of any of these RDBMSs on a single server. Even though with SQL Server there's this possibility to install as much as 32 instances on one box, there are use cases in which you would have, you like to have maybe 2 on one box. I mean, I've worked in environments where that has happened, and they have valid reasons for doing that. But obviously, you wouldn't find that in a production environment. So it might be a case where you have a test server or a UAT server where you have multiple installation. And if I say multiple, I always recommend maximum of 2. So in a case where you have, more than one installation of SQL Server instance, each of those instances have their own operating system, and the operating system for each of them is visible to each of them. So the operating system on instance A is not visible to the one on instance B, and vice versa. So what does SQL OS do? It performs all the critical functions below, and I'll take them one after the other. So this first one says it's responsible for scheduling threads for CPU consumption with the help of its own scheduler. All right, now this is something to actually talk about. I'm going to bring up my task manager, and if I go into performance, you would see that let me bring it closer and expand it a little bit. All right, so you would see that we have here, I have one socket and I have 4 cores and I have logical processors, which is 8. In this case, for each logical processor for SQL Server is a scheduler. So a scheduler and the processor is a one-to-one relationship. So if you have 16 processors, for example, you would have 16 schedulers. So that's the way it is. So depending on the configuration, so some environments have one socket, they may have 2 cores, but those 2 cores might actually be quad core, and that quad core would mean you ultimately have 8 logical processors, because each of the cores is quad, meaning 4. Okay, so regardless, the logical processor is the most important thing here, whereby each logical processor is also assigned to one scheduler. So what the scheduler does is, for every thread, for every work that SQL Server has to do, there is a scheduler that determines who uses the CPU at every point in time, because there is also one-to-one relationship between the CPU and a worker, and a work, because the CPU is the worker itself and the work. So if you have a work that needs to use the CPU, it is a one-to-one relationship. You can't have multiple work going on one CPU. So SQL Server has its own scheduler that manages these things, that who uses the CPU at a point in time. And this is where the SQL OS come to play. And you will find out that in most threads, they are run in cooperative mode. And what do we mean by that? Now, there's a concept called non-preemptive and preemptive. Every operating system, most operating system you find out there, run in this mode, which is the preemptive mode. And what that mode does is, going back to what I wrote here, it means that SQL OS, which is a thread or worker, can spend as much time it needs on the CPU until its task is finished. Now, this is opposite to how Windows operating work, which runs in preemptive mode. Now, the preemptive mode is such that it encourages something called context switching. Okay, and what we mean by context switching is such that if if a work is going on SQL Server on a CPU, for example, and the operating system thinks it is better for another work which has higher priority to work, what it does is it stops the current work and then it gives the CPU to the other one that he thinks it needs it more urgently. And you can imagine how much of process that goes on. For example, looking at my task manager and looking at the processes, you can see that Camtasia here is working. This is working. This is working. Google Chrome, if I open more pages for Google Chrome, each of them will be working. I have this working. All these things are different things working. Now, there are other background processes that are doing, different bunch of work. So what happens with the preemptive mode is, if this is working and all of a sudden this becomes more priority, it takes the CPU off this and switches to that one. Later on, it takes the switch around to another, and you'll find out that within seconds, you would have seen the switch going on multiple times. Now, the fact that it switches a lot of time is CPU bound in its own. And that's not good for SQL Server. Because if SQL Server needs to do its work, it doesn't like, all this kind of disturbances. And that's why they had to introduce the SQL OS so that it can work in a preemptive mode. So what this preemptive mode does is it allows a particular thread to finish its work, such that others can wait for it to finish, because context switching is CPU bound itself, right? So that's the difference between preemptive and non-preemptive. So the operating system as a whole itself, the Windows operating system uses the preemptive mode, which encourages a lot of context switching. But the other one, which is the non-preemptive scheduling, it just allows the thread, like I've said here, the thread or worker to spend as much time as it needs on the CPU until its task is finished. So this is one of the, important concept about SQL OS, and it will get to a point when we start talking about the performance tuning, we will now see where wait types come to play. And that is where, when we see wait types, you will see some in running state, you will see some in suspended, and you will see some in runnable. So that's to tell you, when this is running, every other has to wait. Okay, this is also waiting. So, but it's saying this runnable means it's waiting, but it's available to work. As soon as this finishes, if it goes to that. But this is actually waiting completely because it's not ready to work because it's still waiting for other ones. But we'll go into all these, wait types in the course. So the other part is the memory management. So there are several components within memory from SQL Server and SQL OS, which determines how much is released to each of the components. So for example, we have the plan cache, we have the CLR, we have the lock manager. So I know we talked about memory management, for the Relational Engine before, but within that, SQL OS also do some memory management as well. And what that means is, for example, if a CLR is an external call to SQL Server. So you can be within SQL Server, for example, and you run a C# code. You can run a .NET code. Where's that sharp? Yeah. So you can run a C# code within SQL Server. Now, if SQL Server is now saying that, okay, this CLR code is taking a lot of memory, it can ignite something called the garbage collector. And what the garbage collector does is it looks, into the memory and then finds the ones that are idle or that are no longer in use, and then it tries to release them. So the memory management that the SQL OS does is, for example, like this, whereby it just, does extra work to look out for idle areas within the memory and then assign it to other ones that need the memory. So it does its own kind of memory management, but it's also part of what it does, which is quite different to the Relational Engine. It's like saying they do memory management at different levels. You can say that. So here we're talking about the hosting services for external components such as CLR. I talked about the CLR just now. So it allows the CLR to happen. That's pretty much what this is saying. So the SQL OS is, the functionality that helps us to have all these external procedure calls to happen. And given the example that I gave before, that it can ignite the garbage collector, just to manage the whole memory thing. And it does the exception handling as well. So if you have like a stop procedure that is being configured or that is being written to have error logic within it, so that error handling is being done by the SQL OS as well. So this is pretty much what SQL OS does, but like I said, we will also go deeper into this part later on, which is the wait states, the running, runnable, and those other wait states that I mentioned before. So this is everything about the architecture of SQL Server that you can think of. Now, I'll recommend that after we have gone through a whole bunch of exercises and projects and all of that, I recommend you watch this video again, so that a lot of things that you probably don't understand now will then make sense to you. Okay, so this is where I'm going to stop today. And I know I have said quite a lot. It's quite, daunting to absorb all of these things in just one session, but it is, trust me, it is very important before we actually start doing a bunch of other things. So the next slide is talking about the next steps from now. So we're going to start off with several projects during the course of this training. And the first one will be to build your own infrastructure in a virtualized environment, which is going to be clustered. So building your environment means having your own domain controller, having your own infrastructure like it is your company's infrastructure, right? So the reason I have chosen to do this is because a lot of trainings that I personally went on before, they just teach you these things. They teach you how to configure, how to do all those things, and they teach you very well, but they forget that you do not have any experience at all. So when you go into interviews, people ask you questions based on the fact that you already have experience. So you can imagine someone who does not have a domain controller in their environment. They will not have reason to connect remotely onto a server. Everything will probably be local on their box. Now, when you intend to connect remotely, you use something called the remote desktop, which is this MSTCP. All right, now, if you don't have reason to connect remotely to a server, how would you know how to use remote desktop? And you can find yourself in an interview where they just give you access to a server, and because you have never logged on to a real server before, you don't even know the right thing to do. Even though you know SQL very well, you know how to configure things, you know the architecture and everything, you can talk about it, but that singular thing can actually ruin your interview, not knowing how to do this connection. Or you eventually got the job and your manager, the day you started, or maybe like 2 days after, they've given you a login and everything, and there's a crisis that day, that you're the only one that can save them because you're the only DBA they just employed. But you're having to struggle to learn how to connect to a remote server. These are things that are important, little things, but they're important. And that's why it's important for you to have your own entire infrastructure in your own virtualized environment using VMware. So as you have that, you would also build your own cloud infrastructure using Amazon Web Services. So this will also help you to learn about cloud computing. So we'll go into the security side of things, security groups, firewalls, and all of that. So you will build your own high availability solution, which is always on. And in the course of doing that, you learn the configuration best practices and the exact things you must do when you get a job. And also you will know all the above, which will allow you to speak freely about your experience at the interview. And in addition, you will build all other Microsoft technologies in your environment and learn the differences between them all. So you build mirroring, log shipping, replication, clustering. You do all of these things. And on your environments, we will engage you to do all of these things. So you do security, you learn about TDE, which is transparent database encryption. We will get you to work with SSL. We'll get you to work with logins and users, performance tuning, indexes, troubleshooting, locking and deadlocks, wait states, transaction logs. It was something called the VLF we need to talk about. All those things, you'll get to learn them. Then we'll demo recovery strategies and then make you to recover. We'll invoke disaster, and then you will have to recover to different scenarios. So there's the file group recovery, the page recovery, database recovery, table recovery, and all these things. For those who are from the Oracle background, this file group is as good as, say, the table space recovery. All right, so then auditing, we'll talk about auditing as well, which is the database and server audit specification. And as well, there are next steps, which is automation. We'll deal with using Ola Halengrin backups tool, which will help you to automate your backups. He also has this tool for index management and maintenance plans and how to document your work, because it's very important that you know how to do documentations. I'll show you some of the sample documentations that I have done in the past, and it will help you to also learn this thing. And having gone through all these things, I can assure you, you can walk into any interview at any time confidently and just do your thing. So this is going to be the end of today's session. So do you have any questions? I'm going to unmute you guys now so that we can actually have discussion. Okay. I know it's been a lot. It's been a lot. I hope I haven't, bombarded you with too many information.
I mean, to me, you are not, but there's a whole lot of information, like very, very interesting information. I mean, I'm just overwhelmed for now, like for real. Like, I need to like go back, sit down, and digest this thing, like eat it like bread and egg.
Absolutely. Absolutely.
But to me, I actually like I can make comparison from what you have taught today with Oracle and
Absolutely, yeah.
SQL.
Yeah, that's why I'm trying to
So
chip in the Oracle things because I know you are from an Oracle background, so it will help you to make a comparison and say, okay, oh, I know this about Oracle. I know Oracle uses extents and pages as well, so you can, make
right,
such comparison.
and you know, actually, I actually even before this class, I saw that we're going to do architecture today. I actually
Mm-hmm.
went and read some stuff online, and
Okay.
pretty much most of what I read online is just deep into what you're saying, and I can actually it's easily for me to like catch up, with
Mm.
you and
Okay.
whatnot, and
Good.
it's
Good.
yeah. I'm just gonna like go back and watch the video and play the rest, the ones that I felt like I didn't actually read before this class,
Yeah.
which is part of the OS. And I read some part about the relational engine. I
Yeah.
read some about
Okay.
the storage engine as well. And it's just like the more bullet point that you put really help me to understand more, and also the paging, different types of paging and all that.
Yeah. Mm. Okay.
Yeah,
Cool.
it's really yeah.
Cool, cool. All right. So the videos that you will receive, you're not going to receive just this video. You will receive a lot of videos because you're going to be very busy during the week. It's going to be, it's going to keep you very busy. Trust me. So I'll send all the videos that you need to, start working, and hopefully in the next 4 weeks you can call yourself a full-fledged SQL DBA. Yeah. All right. Cool. All
Yeah,
right.
and also I'll make another point about the Amazon Web Services. It's really something that I've been trying to like, trying to get into for quite some time now, because I actually was trying to get a job with
Oh, right.
Amazon itself. Yeah, and I actually the part of description, job description was Amazon Web Service, and I was
Oh.
actually doing the interview, but they said, we can see that you have a little bit of experience, but we want somebody more in depth about those things, and stuff like that. But actually helped me to understand more about how Amazon services, the kind of services they render,
Mm-hmm.
how they, in terms of regions,
Yeah.
how this and that, and elastic,
Elastic
and all of that.
compute. Yeah. All those.
And so, it's been a long time I've been doing web services, so,
Okay.
and how they prioritize their job in terms of,
Mm.
this service, this one is out, you can actually relocate to another service in the area,
Exactly.
cheaper.
Yes. 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 We'll do all of that. We'll go into private networks. You can actually configure your own VPC, which is like the VPN, but it's called the virtual private cloud. So you can have your own VPC in the cloud such that you can have just one entry into your server, but all the other servers you cannot from the public connect to them, okay, because they will be contained within the private network. So you can have just one server that is facing the public. So once you get into that server, from that server you can then go into other servers using the VPC, and then you can also have the elastic IP, which can help you to have a static IP, because each time you restart it, it will change the IP. It works like the DHCP. But I mean, we'll go into all that detail. Don't worry. So you're covered in that area as well. All right, cool. So Femi Okuta, do you have any question, any recommendation or addition?
Any question? I also, I was looking into memory today. I had some issue my lab at home.
Yeah.
Trying to troubleshoot. And some of the things you said, I didn't even know that it was about who manages them. I thought we'll be the ones who manage team memory.
Okay.
So sort of cleared my mind now. Okay, it's not me who has to
Do all those things.
I didn't know that because I did a few things. I had to clear the DBCC, clear what's it called now? Just to clear the cache.
Yeah.
I tried to go back to the task manager. I tried to run a few queries to see what my memory was, but I was seeing the same thing. I was like, with this thing that I've done, I should get another result. But knowing this now that it's SQL Server who manages it makes it clearer.
Cool. Cool. All right. So yeah, like I said, SQL Server is a mature RDBMS, and a lot of people are flocking into it. And before it gets overloaded, it's better you get into it too as fast as you can. But I don't see it. I mean, it's gonna stay for for a long time, except the fact that Amazon now has database as a service with our RDS solution, whereby they manage all this DBA work. But it doesn't mean that the place of a DBA will be taken away, at least not now. So that's it. Okay. All right. So yeah, I'm gonna leave you guys here today, and you can expect my email. And yeah, that reminds me. Now, what I would do is, because of I want to give you free access to our portal, because I don't know to what extent you know how to code in SQL, but it is very important for you to be solid in SQL as well. So what I'll do is I'll give you free access to our portal, where you can learn SQL. You can omit certain things that you think you already know, but it might be important for you to also know it as T-SQL, which is the SQL Server flavor. Yeah. So once you are able to cover all those areas, you won't be lacking when we start using T-SQL to do some things. So say, for example, when we get into TDE, it's one thing to configure TDE. It's another thing to automate it. So we're going to be using T-SQL to automate TDE. So if you have an environment that they very often configure TDE, you need to have like a script that you can just run and it configures everything for you. You understand? But if you don't have solid knowledge of T-SQL, that might be a daunting task for you. So I will send you the email also to give you access to that portal, so that as alongside as you're learning to configure these things, you can also be learning SQL on the side. Okay. All right. So yeah, so that's it. So I'll see you next week, so that we can catch up and see where we are with things.
A quick question: what do I need to build my infrastructure? What do you recommend?
The only thing I'm going to recommend right now is your computer, your host computer. You're going to start with the VMware before we go into the cloud. So your host computer, you want to try and have good configuration. The video I'll send to you actually documented everything. So in terms of the memory and the CPU resources, you want to try and have enough. So in my own case, I have 16 gig of memory. If you are able to have as much, it's good. If not, if you have 8 gig, it's good. If you have 4 gig, you might struggle. So you can just bear that in mind.
So 8 gig, you can struggle with 8 gig?
No, 8 gig is fine. You can, 8 gig is fine. It's actually fine. With 4 gig, okay, yeah, so 8 gig is good enough to do the things you want to do. Yeah.
And I can upgrade it as well. I can have,
yeah, if you can upgrade, then it's even better. Yeah. All right. Cool. All right. So I'll see you next week, guys.
Okay. Okay, so it's gonna be Saturday.
I'll communicate that to you because I do have another series that I run on Saturdays. So, but
Okay.
I may no, if it's gonna be Saturday, it won't be next week Saturday, but it can be Saturday going forward from upper weekend.
Okay.
All right. All right then. Have a nice
Thank
one.
you so much for this for this class and so much appreciated.
You're very
And
much welcome.
also be nice meeting you. All right, also be nice meeting you as well. All right.
All right then. Cheers. Bye.